And some of you may be aware that I detailed that in the microbiome and dysbiosis program that we started back in 2015 and which took me 2 years to complete into 2017. So I'll talk a little bit about that later as related to that video series and the resulting little textbook publication. Now let's talk about secretory IgA. So secretory IgA is the chief immune globulin on mucosal surfaces. It is defensive against infections, but it's also protective or tolerogenic toward beneficial bacteria. Secretory IgA deficiency is the most common genotropic immunodeficiency, affecting about 1 per 600 people. Pleasant short-term stress actually increases secretory IgA levels, but chronic long-term stress actually reduces secretory IgA levels. Many nutrients and probiotics can stimulate or support production of secretory IgA. Remember that with immune globulins, we typically want low basal levels followed by appropriate but not exaggerated increase when faced with a challenge. Also, since we're on the topic of immunoglobulins, I want to remind you that serum immunoglobulins are generally meaningless or at least secondary in the fight against viral infections. Patients with A-gamma-globulinemia typically have normal courses of viral infections and a normal response to viral vaccinations. So let's look at some research related to secretory IgA and vitamin D on the following page. This article was published in 2014, stating vitamin D3 deficiency results in dysfunctions of immunity with severe fatigue and depression in a variety of diseases. And to her credit, this author provides a lot of really excellent detailed information within the scope of only 2 sentences. She states that secretory IgA, another biochemical barrier of skin and mucosa, is supported by vitamin D, rather indirectly by inducing the expression of the Fc receptor on phagocytes, leading to enhanced binding of secretory IgA. She states, furthermore, vitamin D induces CC motif chemokine receptor 10 in human B cells, resulting in enhanced B cell differentiation into IgA secretory cells with the potential for homing to the gut. So you can pause the video if you want to read that again and let it sink in, but she does provide in 2 sentences some really good detail on how vitamin D supports secretory IgA defenses. Now let's take a look at a clinical trial which was recently published in 2015. This is Journal of Sports Sciences. The effects of 14 weeks of vitamin D supplementation on antimicrobial peptides and proteins in athletes. And you can see here from the abstract that the authors state only in the vitamin D group, the saliva secretory IgA and cathelicidin secretion rates increased over time. A daily 5,000 international unit vitamin D3 supplement has a beneficial effect on upregulating the expression of secretory IgA and cathelicidin in athletes during a winter training period, which could improve resistance to respiratory infections. Now let's take a look at one paragraph from this article where they focus in on the effect of vitamin D on antimicrobial peptides and secretory IgA. Antimicrobial peptides are involved in the direct inactivation of viruses through membrane destabilization. They are produced by epithelial cells and macrophages, and in the lungs are secreted into the biofilm covering the inner surface of the airways, thereby creating a barrier that is chemically lethal to microbes. The plasma cathelicidin concentration in athletes with high-level vitamin D status was significantly higher than in athletes with low-level vitamin D status. So what they refer to here as high-level vitamin D status is actually quite good. Anything above 80 is at least adequate, and here they're talking about above 90, so that is actually quite adequate. And here when they talk about deficiency, this is gross deficiency. So what they're showing here in this review of the literature is that higher vitamin D levels correlate with higher levels of antimicrobial peptides, specifically cathelicidin. The authors also state that in addition, the average secretory IgA secretion rate in individuals with high levels of vitamin D was significantly higher than in groups having adequate, inadequate, or deficient vitamin D. So again, in both situations, with antimicrobial peptides and with secretory IgA, we see a dose-response relationship. The higher the vitamin D level, the higher the level of protection from these antimicrobial peptides. Now let's talk about part 7 of these external barrier components. We're talking about protective fluids, including mucus, saliva, and tears. Mucosal tissues secrete mucus, which is a combination of water, the mucin hydrophilic protein, which provides protection and lubrication. Lacrimal glands secrete tears. This is a combination of